Hello, everybody. My name is ZacharyMollinedo, and today we're going to be talking about my operating systems programming assignment 2, which mainly deals with a CPU scheduling simulator. The two scheduling algorithms that I went with is first come, first serve and round robin scheduling. Today we're going to be talking about mainly round robin scheduling, as that's the AI prompt that I chose to go with, as you can see here. And we're also going to be talking about the upgrade part and also the actual code itself. So let's get straight into the AI prompt, which is right here. Explain round robin scheduling and how the time quantum affects waiting time, turnaround time, responsiveness, and context switching. So first, let's get into the actual meat and bones, which is round robin scheduling. It's a CPU scheduling algorithm used in time-sharing operating systems, and it pretty much gives every process a fair chance in their CPU time. So think of it like a line in Disney. Everyone has to wait their turn in a queue. Everyone will get their fair chance to ride the ride. Such as, I don't know, perfect example could be the Tron ride in Magic Kingdom. Everyone's got to wait in the line, and everyone will eventually get to hop onto the light cycle at some point, which is pretty much the same as round robin. Processes are put in a queue, such as in a line. The CPU is assigned to the first process for a fixed amount of time, called the time quantum. And then if the process finishes before the quantum expires, it then leaves the system. If the process still needs CPU time when the quantum expires, it is preempted and moved to the end of the ready queue, and then the next process enters the queue, such as this right here, and the execution order, which is P1, P2, P3, and then back to P1, P2, P3, and then back to P1. The time quantum does affect system performance with waiting time, which is pretty much how much time a process spends in the queue waiting for CPU access. The smaller the quantum, processes are interrupted frequently and must wait through many rotations. Whether if it's a large quantum, they spend less time cycling through the queue, which can reduce waiting time. Turnaround time is pretty much dealing with the time it takes from the process to arrive until completion. Smaller the quantum, uh, it deals with excessive content switching, which can delay completion and increase the turnaround time compared to a very large quantum, which may hurt short jobs waiting behind longer um, processes. What you want is usually something in the middle. Responsiveness is the exact same thing. Deals with how quickly a process receives CPU time after arriving. Smaller the quantum, deals with excellent responsiveness because the CPU can access each process quickly and frequently. And a larger quantum deals with poorer responsiveness because a process may have to wait a longer time before getting its turn. Context switch, Jesus, uh, is pretty much when the operating system saves the state of one process and loads another process. So a smaller quantum deals with many context switches, and larger deals with fewer. So right here, dealing with the trade-off summary, we have quantum size. If it's very small, everything's usually higher, but your responsiveness is excellent. If it's very large, everything's lower, but your responsiveness is poor. So you want something kind of in the middle. Now, since we're done talking about this, I'm going to move on, the AI prompt, I mean. Now I'm going to move on to my code. And then what we're gonna do is I'm gonna first slowly go through each part, not each part of the code, but I'm gonna slowly show the code so everyone gets their fair chance to take a look. If anyone has any questions and all that. Just gonna go very slowly. This is obviously dealing with first come, first serve and round robin. Obviously, we're focusing on round robin the most. Here you go. Go through all of this. Here you are. This is first come, first serve scheduling right here. Then we have round robin scheduling. Almost there. And then just the results. Perfect. All right. So let's get to the section of the code I wanted to talk about, which is right here. Around there, pretty much around this part. So this whole part of the code deals with prioritizing not prioritizing, but pretty much calculating time remaining, time quantum. Uh, we're dealing with turnaround times and waiting times and all that. This is all based on what we learned throughout the lecture using the scheduling formulas to talk about turnaround time, waiting time, completion time, time remaining, any type of time dealing with round robin scheduling. So now I'm actually going to show you the code working. So we're going to do 5 processes. Okay, we're going to do a 0, 8, a 1 and a 4, a 2 and a 9. Then we're going to do a 3 and a 5, and then a 4 and a 2. And now for the round robin, we're going to do a 2 for quantum. And here we are dealing with this. Obviously, inputting that. This is first come, first serve scheduling with our Gantt chart. This chart shows our process ID, arrival, burst, waiting, turnaround. Average time, dealing with round robin. Here's the chart once again going through which processes got what. Same thing here, average waiting time, average turnaround time. With that being said, um, so if you want, let's do that actually. So if you look at the Gantt chart for first come, first serve scheduling, since this is a non-preemptive, each process runs until completion before the next process can get CPU time, compared to round robin, where processes appear multiple times because they are preempted after each time quantum. So pretty much each time kind of likes to skip and try to get ahead in the line, trying to finish themselves off. That's why 5 is immediately gone in the second time around, as you can see here. And then 2 is gone because it's process finished. So then 3 and 4 come along. And then 4 is gone because it finished. And then now it's just 1 and 3. 1 got finished, and then 3 was the last to finish. And now let's get to the next part, the exciting part. We're going to now upgrade the code. So I'm going to do this. I have a C program that simulates round robin CPU scheduling. That's not how you spell scheduling. How do you spell that? It is like this. I want to modify. That's not how you spell modify. It so I can run the same process list with 2 different totals to values and compare average waiting time and time. Okay, to do this, here's my code. Let me copy the code super quickly if I could get there. Here we are. Okay, I'm going to just here. Let's see what it does. Let me see if it can make it a little bit more simpler. Okay, so I'm going to copy this, enter time quantum. Let's go back. Here we are. I think this is it right here. Okay, so we're gonna do that. So we're getting rid of right about there, round robin processes M. Oh boy, that did not work. Hold on. Ah, trying to see where I went wrong. Replace this section with end-to-end quantum. That's right here, right? Where is that end-to-end quantum? Here it is. And oh, that's right. I gotta change it now. Let me just do this and just do that instead. There we go. Okay, that should be better. Sorry about that. That was a little scary, but that's usually how it goes when you code with AI. Okay, perfect. Now, let's try running it like this. All right, let me go back and make sure I actually run that the way it says to so that we can see the change. So it's going to be, let me just write this down super quick so that I know what I'm doing here. So we're dealing with 4, 0, 10, 1, 5, 2, 8, 3, 6, 2, and 6. Done. All right. We're going to do 4 processes. We're going to do 0, 10, 1, 5, 2, 8, 3, 6. Let that happen. We're going to do 2. I'm going to do 6. And there we go. This is obviously talking about when the time quantum is 6, and this one deals with the time quantum that's 2. And there we go. That's our upgrade completed, slotted in. Pretty much the upgrade, what we did here is we're running round robin pretty much at the same time with 2 different time quantums. So it's easy to compare which time quantum works better and which one doesn't with your processes. With that being said, I believe that is all for this video. Um, make sure the actually not make sure the toughest part definitely about this was getting used to how time quantum affects everything and how important it is to keep in mind that time quantum heavily affects all your other times like waiting time, turnaround time, responsiveness, and so on and so forth. With that being said, thank you for watching and have a great day.